Carbide burrs, those precision rotary tools crafted from tungsten carbide for grinding, shaping, and deburring across metals, woods, and composites, offer immense versatility that can be further enhanced through thoughtful customizations and accessories, allowing users to tailor them precisely to specialized tasks without relying solely on off-the-shelf options. While standard burrs excel in general applications, modifications like shank extensions or custom sharpening address limitations in reach, edge retention, or compatibility, transforming a basic tool into a bespoke instrument for intricate work such as aerospace prototyping or artistic engraving. These adaptations not only extend the burr's functionality, but also improve safety and efficiency by reducing the need for awkward tool angles or frequent replacements, ultimately saving time and resources in professional or hobbyist workshops. By integrating add-ons like flexible shaft adapters or custom coatings, users can optimize performance for unique challenges, ensuring cleaner cuts and longer tool life. This article explores these customizations in depth, verbally detailing their implementation, benefits, and synergies with complementary tools, all while emphasizing practical, hands-on approaches that democratize advanced fabrication. One of the most straightforward yet impactful customizations involves adding shank extensions, which elongate the burr's connection to the rotary tool, providing extended reach into confined spaces or deep recesses where standard lengths fall short. These extensions, typically made from hardened steel or carbide-compatible alloys, attach via threaded couplers or set screw mechanisms to the burr's 1/8 inch or 1/4 inch shank, allowing lengths from 2 to 12 inches depending on the task. Imagine threading a 6-inch extension onto a flame-shaped burr for accessing the interior curves of a pipe fitting during weld cleanup, where the added reach prevents the need to contort the entire tool body into tight spots. The benefits shine in specialized tasks like engine porting or cavity detailing in molds, where direct access minimizes vibration and overcutting on adjacent surfaces, reducing material waste by up to 30% and enhancing precision in high-stakes environments. For instance, in jewelry making, an extended burr enables delicate undercuts on ring settings without risking hand strain from forced angles. Verbally guiding the setup, select an extension with matching shank diameter and secure it firmly with a torque wrench at 1.5 Newton-meters to avoid slippage, then test at low RPM, 5,000, for balance before ramping up, ensuring the added length doesn't amplify harmonics that could lead to wobbling. This simple mod not only broadens application scope, but also promotes ergonomic operation as users maintain a comfortable grip distance from hazardous debris. Custom sharpening represents a more advanced modification, empowering users to restore or refine a burr's flutes to suit specific materials or cutting styles, extending its lifespan beyond factory edges that may dull unevenly after prolonged use on abrasive substrates. This process involves using diamond files, grinding wheels, or even electrochemical honing kits to reprofile the helical grooves, adjusting the rake angle, typically 10 to 20 degrees for general use, to a steeper 25 degrees for hard metals like titanium, which improves chip evacuation and reduces binding during aggressive stock removal. The benefits are profound for specialized tasks. A custom sharpened double-cut burr, with its crossed flutes honed to a finer pitch, excels in aluminum deburring by minimizing gumming and heat buildup, allowing for smoother finishes in aerospace component fabrication where surface integrity is critical. Conversely, sharpening a single-cut burr with coarser teeth optimizes it for wood carving, shearing fibers cleanly without splintering delicate grains. To perform this, start by securing the burr in a vise with soft jaws to prevent shank damage. Then gently file along the flute direction under magnification, aiming for uniform bevels and checking balance by spinning it manually. Always wear eye protection, as carbide shards can fly during the process. This customization not only defers replacement costs, potentially saving hundreds on high-end burrs, but also allows personalization, such as creating a hybrid edge for mixed material projects, fostering innovation in custom toolmaking while maintaining the Carbide's inherent hardness rating of 90+ Rockwell. Beyond core modifications, accessories like shank reducers or quick change adapters further customize Carbide burrs by enhancing compatibility with diverse rotary systems, bridging gaps between tool types for seamless workflow integration. A shank reducer, for example, steps down a 1/4 inch burr shank to fit 1/8 inch colettes on compact Dremel-style tools, enabling the use of larger, more robust burrs for heavy-duty tasks like weld blending without upgrading the entire setup. Its benefits lie in versatility for specialized applications, such as adapting industrial-grade burrs for precision electronics enclosure trimming, where the reducer's secure lock prevents slippage under torque. Quick change systems, featuring magnetic or spring-loaded chucks, allow rapid swaps between burrs mid-project, ideal for multi-step processes like roughing with a cylindrical burr, followed by finishing with an oval one, cutting setup time by 50% and reducing downtime in production runs. Verbally detailing installation. Align the adapter's bore with the burr shank, engage the locking mechanism with a quarter turn, and verify retention by tugging firmly before operation. These add-ons not only streamline efficiency, but also enhance safety by minimizing exposed moving parts during changes. A particularly transformative compatibility arises with flexible shafts, which pair with customized Carbide burrs to deliver maneuverability in awkward positions, effectively turning rigid rotary tools into snake-like extensions for overhead or inverted work. These shafts, composed of braided steel cables encased in a protective sheath, connect via universal joints to the power source and burr shank, transmitting rotation with minimal flex loss while absorbing vibrations for steadier control. For specialized tasks like sculpture detailing or under-vehicle repairs, attaching an extended, custom-sharpened tree-shaped burr to a 3-foot flexible shaft allows access to concave wooden reliefs or chassis contours without ladders or awkward postures, benefiting from the shaft's torque retention up to 90% efficiency at 20,000 RPM. To maintain cutting power in remote areas. Conceptual drawings illustrate this synergy vividly. Envision a side-view sketch of the setup as a sinuous line representing the flexible shaft curving at 90 degrees around an obstacle, with the burr head depicted as a tapered point engaging a deep groove. The arrowed rotation path spirals along the shaft's length, showing smooth torque transfer without kinks, while cross-sectional insets highlight the universal joint's ball-bearing pivot points, ensuring alignment. Another drawing might zoom on the connection, portraying the shank reducer clamping the burr securely amid the shaft's helical cable, with dashed lines indicating vibration dampening waves dissipating before reaching the user's handheld controller. This compatibility unlocks applications in restoration work or model building, where the flexible shaft's 1 to 5 foot lengths adapt to custom extensions, providing ergonomic freedom and precision that rigid tools can't match. Coatings and handles round out customization options, offering protective or ergonomic enhancements for prolonged or hazardous use. Applying a thin film coating like titanium nitride, TIN, via a DIY electrostatic sprayer or professional service increases wear resistance on the burr's flutes, ideal for abrasive tasks such as grinding composites, where it reduces friction by 20 to 30% and extends edge life for high-volume production. Benefits include cooler operation and less frequent sharpenings, particularly valuable in tasks involving heat-sensitive plastics. Ergonomic handles, custom machined from aluminum with rubber grips, attached to the tool body for better control during extended sessions, reducing hand fatigue in detailed engraving. Verbally, select a handle with modular mounting holes to accommodate extensions, securing it with set screws for a vibration-free hold. Conceptual drawings for these might depict a longitudinal section of a coated burr with a golden tin layer enveloping the flutes like armor, arrows showing deflected abrasive particles bouncing away during a cut. For the handle, a 3D isometric view illustrates the grip's contoured form wrapping the shaft, with force vectors demonstrating balanced weight distribution that stabilizes the tool path in curved motions. In essence, customizing Carbide burrs through extensions sharpening, and accessories like flexible shaft compatibilities elevates them from generic grinders to specialized powerhouses, tailored for the nuances of each task while prioritizing safety, efficiency, and innovation. By verbally navigating these modifications, from threading and extension for deep reach precision to honing edges for material specific bite, users gain the confidence to experiment, adapting tools to unique challenges in fabrication, artistry, or repair. Whether integrating quick changers for speed or coatings for durability, these enhancements not only amplify performance, but also encourage sustainable practices by maximizing tool longevity, ensuring that every spin yields optimal results in a world of bespoke craftsmanship.